So, hello everyone. I'm back again with another video. This time I'm going to be showing you guys a DP question, dynamic programming question. So, you guys might have done the other versions of buy and sell stock with two pointer methods and similar other methods. So, this question is a little bit more intriguing because there are some other things as well that we have to take into consideration while doing this question. One of the things is a transaction fee, and apart from that, unlike the other questions, in this you have a decision to make, so it's not as simple as just keeping track of both sides and then selling stocks as that. All right, so I'll explain to you an easy DP method and why I believe that, like, in general, this approach to DP is far easier than the other way with the arrays. So yeah, let me show you guys. Let me first explain the question. You're given an array prices with prices of I is the price of the stock on the given ith day, and you have an integer fee which is here, which represents the transaction fee. Find the maximum profit you can achieve. You may complete as many transactions as you like, so there's no limit on transactions, but you need to pay a transaction fee on each transaction. Alright, that's cool. Alright. So how it works is that you may not engage in multiple transactions simultaneously. Okay, so if you buy a stock here, you can only buy another stock when you decide to sell that stock. And you can only and the transaction fee is applied when you sell the stock. Is charged one for each purchase and sale. So let's take this example let's take this example. All right. So you have 1, 3, 2, 8, 4, 9. So the maximum profit is when you buy the stock first, then you sell it at 8, so you get 7 profit, and then you buy this stock at 4 and sell it at 9. You get it? 1, 8, 4, 9, and we lose 2 for each transaction fee. So you can't just keep buying and selling stock like that because there's a transaction fee involved as well. And the transaction fee is applied at the time of selling. Okay, so let's do this question. So the way I like to do DP questions in general is first think about a recursive approach, and then we cache the recursive function. So in that, for Python, within Leetcode we have a variable for from functools import cache. So what this does is basically whenever you define a function, for example, we define a DP function and it takes certain parameters. Let's say it involves certain parameters I, j, k, etc. It stores a trace of this function. So I, j, k. So anytime the function is called again with the same variables, it saves it within the cache. So it will directly return the answer and it does not have to compute the entire thing again. So if you guys know that in general, DP is where you store cached answers. When you have repeating subproblems, you can store it here. So similarly, yeah, this is how we do it in this case. So yeah, let's define the DP function. And before that, so the way we use this cache is before defining any DP function, all you have to do is you have to add a cache on top of it. So now it's cached. All right. So let's look at first, before any DP question, what I like to do is think about what parameters are changing and the values, what parameters are dependent on. So you'll obviously need a variable to check when the array ends. So that's there in almost every DP question to keep track of the current price what we are taking. So we'll use an I variable for that. What else do we need? We also need to know at that point when we have to make a decision, are we holding the stock or are we not holding the stock? So that's very important because you can only buy a stock when you're not holding and you can only sell a stock when you're holding. So let me call that holding, which will be a Boolean variable, true or false. All right. So now once you have this combination, we are done with the DP function. So let me just keep this for now. And now let's return. All right. Let's see what we pass. So return DP of. So initially, what do we have? We have to start from the first price. So we return 0 first, and initially we are not holding anything. So we have to start the function with a false. All right. So let's do the function now. So first things first. If I is equal to the length of prices. So what does this mean? Once you reach the end of this prices array, at that point we have to return 0 because there is nothing after that, because you have reached the end of the prices array, right? There's nothing more to compute. So now this part is very important. So let's decide on whether to buy or sell the stock. All right. So now this is simple. So if you are not holding anything, all right. So now you have nothing with you. Holding is false initially. Then you have two options. So you have come to the first decision point. Do you want to buy one or do you want to not buy one and skip it? So let's consider those two options. You want to buy one or you want to skip one. All right, the first variable. So let's consider both these options. So let's consider the first case where you buy the one. Okay, so now you've bought this one. So you have lost $1. All right. So how do you represent that? Minus prices of I. So this is what you have lost $1, and now you want to compute the value for the rest of the array. So the way you do that is dp of I plus 1. Now you want to go ahead. Okay, I've bought this one. Now whatever happens ahead happens. I've bought this one. Let's see what the future awaits. All right. So you've bought this one. So you move I plus 1. And also now you're holding something. Since you've bought the stock, you are holding something. So you have to change it to true. So you're holding something. So now the other decision is you just want to skip it. You don't really care about what happens. So you just want to skip be buying or selling anything. So in that case, all you have to do is just move directly to the next one and you keep it as it is, false. You don't really want to change what it is because you're moving to the next one and you're still not holding anything. At this decision point, first you decide to buy it by subtracting prices of I and changing it to true. And the second decision you make is to skip it, which is to move to the next one, 3, without buying anything. So it's still false. Now let's move to the else point. Now at this point, you're not holding anything. So now we have to consider the case where you are holding anything. So if you are holding stock, at each decision point, you can either decide to sell the stock or skip selling the stock. So let's consider selling first. So when you sell a stock, you gain that amount from that day. What else do you need? You also have to lose minus 2. So minus 2 represents, okay, not minus 2, minus the fee. You at each point when you sell, you have to pay a fee. Like so, that point we will pay the fee by subtracting it, and after that all you have to do is you need to also check beyond that. Okay, so you have sold the stock, whatever happens ahead happens. So how do you represent that? dp of I plus 1 and false. Because you have now sold the stock, you're again back to not holding anything, so we have to pass in a false. So now we can also skip selling. So at this point you don't really have to sell or buy anything, so all you can do is just consider the same thing, I plus 1 and true. So you're not selling your stock, you're just going to the next one and continuing with true. So these are the two cases that we have to consider. Now at the end of the day, so now we have to decide, buying the stock at that point, is buying the stock or skipping the stock the better decision. So the best way to do that, we can just max out both of them. So buy and skip, we max out both of them. And now in the case where we are not holding anything, we have to do the same thing. Answer is equal to max, sell or skip. So this will give you either you want to buy the stock or skip the stock, either you want to sell the stock or skip the stock. And at the end of this function, all you have to do is return the answer. Okay, and so now this should work. You see, it works perfectly. So the way it works is we initially start out at 1. We decide whether to buy or skip the stock. Initially, we go for buying the stock. Cool, we buy the stock. So now at 3, we come back here. Now we're holding something, so we go into the else part. So now we decide to either sell or skip the stock. We consider the case of selling first. So when we sell the stock, we will first we will gain 2, and we also lose 2 in this minus fee part of it, and then we go ahead. So now, so the first case, what we do is we buy this, sell this, buy this, sell this, buy this, sell this. That's the first case. The second case is we buy this, then the second case is, yeah, we buy this, sell this, buy this, sell this, buy this, and skip this. That's how it comes here. And now similarly, yeah, the third case is also, it keeps going like that. You guys can put this in a debugger to check further. So yeah, this output works. And yeah, this is how we do this question. And this is how I would generally implore you to approach DP. So yeah, the time complexity isn't the best, but in general, it is an accepted solution. And in general, I prefer doing this method compared to the uh, bottom-up method. Memoization is always more preferred for me because in general, when you have to define the arrays, three-dimensional, four-dimensional arrays, in this you have a better holding about what parameters you want to change and things like that. So yeah, that is this question. I'll be uploading more videos. So thank you so much.